Good morning, everybody. Today is Monday, January 11th, and today, when you're in class, obviously you're going to take that paper quiz, but while you're at home, hopefully you're going to be watching this video. So today, we are going to talk about solving a system of equations using a different method. So far, we've used about substitution, we've used elimination, but today we're going to talk about actually using graphing, which we've talked a little bit about in class. So a system of equations is it's a system it's a collection, right, of two or more equations. As you get into algebra 2, you'll start using like 3 and 4 equations, but primarily we're just going to focus on 2. What if we graph 2 equations on the same graph? So here's our first example. We're going to go through and graph these 2 equations. So you have y equals negative 2x plus 6. This is in slope-intercept form, so remember we can do mx plus b. B is our starting point, m is our slope. So for the red graph, it's going to start at 6. Okay, and it goes down 2 over 1. It's a negative 2 slope. Okay. Looks like that. And then for our, we'll just say our blue graph, starts at negative 4 and it goes up 3 over 1. Up 1, 2, 3 over 1, 1, 2, 3 over 1, 1, 2, 3 over 1, etc. Okay. So there's our red graph, there's our blue graph. It says, where do these 2 lines intersect? Well, if you look, they touch right here, which is at the point 2 for x and 2 for y. So that intersects at 2, 2. So as we talked about in class, the solution to a system of linear equations is where the 2 lines intersect. Right? We've been using Desmos to check our work. It's the same idea. This point of intersection includes the values for x and y that make both equations true. So if we plug 2 back into these, they would both be true statements. Okay, but what happens if you have 2 equations that have the same slope? How many solutions does that system have? So again, we've used this a little bit, but let's take a look using Desmos. Okay, and this first one is negative 2x plus 6. Okay, and then our second one is y equals negative 2x minus 4. So you can see, even if I continue to zoom out, they look like they're getting closer, but that's just because the numbers are getting smaller, bigger and bigger. But you can see these are actually 2 parallel lines. So what happens in a system of equations if they have the same slope? They are parallel lines, and they never intersect. So what does that mean? No solutions. So, same slope, no solutions. What if they have the same slope and the same y-intercept? So if you take a look at this one, it says y equals negative 2x plus 6. And even though this one's written differently, if we subtract 2x over, it's actually the exact same equation. Now, let's just say that we plug it in anyways, as it was. So we would have 2x plus y equals 6. As you can see, green line, red line here on Desmos to the right, they're the exact same equation. So if they have the same slope and the same y-intercept, this means that it is the same line, which means it's always touching, which means there are infinite solutions. Okay, so how can we check to see if I have found a solution to each of the systems of linear equations? All right, so if I have 2 graphs, right, and we wanted to solve them by graphing, we would just plug them into Desmos, 3x minus 2, and y equals negative 1/2 x plus 3. Okay, we can see that on the graph on the right, our solution is negative 2, 4, so this checks out. So this is the solution. Okay, so how do you check it? Well, graph them and see if that's the correct solution. Same way here. Y equals x plus 4, and y equals negative 2x plus 1. Okay, here's our solution. Solution says 2, 6. That is not correct. The solution, don't mind my handwriting here, is negative 1, 3. Okay? All right, let's continue here. So you find the solution to these systems by graphing. You can check via Desmos. Okay, so I'm going to graph these ones by hand at this time. If you want to go ahead and graph them in Desmos, that works too. This first one starts at negative 1, has a slope of 5, up 1, 2, 3, 4, 5, over 1. 1, 2, 3, 4, 5 over 1 would be somewhere up here. Down 1, 2, 3, 4, 5 over 1. Okay, there's my first line. Oops. There we go. What in the world is happening? Okay, and then the second line was x plus 3. So it starts at 3, goes up 1 over 1. Perfect. There's our intersection. So our solution here was 1, 4. And again, is it quicker to do it in Desmos? Perhaps. Y equals 2 is going to be right there where the y equals 2 axis is. And then the second one starts at a negative 1 and goes up 3, 1, 2, 3, over 4, 1, 2, 3, 4. So there's our second line. And you can see our solution here is at 4, 2. Okay, and then the last line here starts at negative 7, goes down here, goes down 1 over 2, or up 1, left 2. Okay, and then the second one starts at negative 3, goes up 1 over 6, down 1 over 6. Okay, which my line doesn't really touch, but you can see that it's right here. So maybe I'll make a better line. There we go. So that would be at negative 6, negative 3. Okay, so again, you can use Desmos for those. It's probably just as easy either way. Okay, Donato's charges $14 per pizza plus a $1.70 delivery fee. Pizza Hut charges $13 per pizza. So we're going to write the equations. Let's see, Donato's $14 per pizza. So y equals, that's our starting point, 14 plus 170 delivery fee. Okay, so this would be 14x plus 170. Pizza Hut, $13 per pizza. So 13x plus 370 delivery. Okay, how many pizzas do you have to order for the cost to be the same? All right, so this is just basically saying plug it into Desmos. Y equals 14x plus $1.70. Y equals 13x plus 370. Okay, let's go back to our home here. Looks like, ooh, they are close. Space them apart. Looks like it's right there. How many pizzas? Or what variable represents the number of pizzas? In this case, it's the x. Okay. So how many pizzas would we need for the cost to be the same? 2 pizzas. Okay. What variable represents an amount of money? That would be y. In this case, it would be $29.70 after 2 pizzas would be the exact cost. Okay, so that's how you do an application problem with graphing, solving systems. Write up the equation, graph them, see what it would cost to be the same amount, and what your total price is. So you got an exit ticket, similar situation. Go ahead and use Desmos on that, finish that, and submit it to Canvas. Have a great rest of your day, and I'll see you.